buckle your seatbelt because we are on page 2 of this amazing solution set. All right, here we go. Free body diagram. Let's just draw one real quick because I actually have a reason for doing what I'm about to do. The normal on x, the weight of x, we get the force pushing x, and then we have the force on x due to y. This is actually what we want to solve for in this problem. But then we have the force on y due to x, the normal on y, and the weight of y. Now here's the deal. Let's look at the second block here. It turns out the F on y due to x is what makes the mass of y accelerate. And so we have a 4 kilogram block with 4 meters per second squared of acceleration. And it turns out we get 16 newtons worth of force. So this is Fyx. And then by Newton's third law, we just solve for this. By Newton's third law, that's exactly equal to the thing that they're asking us for in the problem. So we also get 16 newtons. All right, a hoop. I for a hoop, that's the only one they don't give you. You're going to memorize it as mr squared. So let's get the rotational kinetic energy. That's 1/2 I omega squared, which is 1/2 mr squared times v squared over r squared, because omega is v over r. These cancel. Oh, isn't that cute? So we get 1/2 mv squared for the rotational kinetic energy. And then for the translational, it's 1/2 mv squared. They're exactly the same in proportion, so it's a 1-to-1 ratio. That's C. Okay, this is a theorem I didn't teach you, but it's a good chance for you to see this. So we've got this sphere, okay, and there is a rule called the parallel axis theorem. So the moment of inertia here is 2/5 mr squared. If you want to know the moment of inertia about any other axis, what you do is you take the distance, in this case it's r, and then you just add mr squared. You add m times the distance squared. So in this case, the distance to the new axis is r, so that's 2/5 mr squared plus mr squared. So that's 2/5 mr squared plus 5/5 mr squared. That gives us 7/5 mr squared. I cannot talk. Awesome. All right. Vector kinetic energy. That's it. Okay, just to be clear, this is like the most common one they give you. Energy is not a vector quantity, so you can totally work with it. All right, we got a toy raft. Oh, look at this constant acceleration being generated. So what that means is horizontally we go to steady speed. Vertically, we are accelerating. So E would probably, I don't think anybody would ever guess C or D. Those are just insanely terrible choices. But you might guess E or A. And the reason E is wrong is that works if you've got a steady speed. But we actually have a steady acceleration, which means it's going to be picking up speed and going faster and faster. Choice A is the right choice. So that is page 2 of the multiple choice exam.